Spaceflight has a significant effect on the health of astronauts. The unique environment of space, with its lack of gravity, isolation and confinement, and exposure to radiation, has a detrimental impact on the human body. This includes effects on the cardiovascular and nervous systems, loss of bone and muscle mass, and decreased ability to fight against pathogens. To ensure successful crewed missions to outer space, it is crucial to understand these changes and find ways to mitigate their effect.
The European Space Agency's SciSpacE activities focus on better understanding the impact of space and its various stressors on the different physical and biological processes, as well as quantifying the impact of space on an astronaut's health. The goal is to find ways to explore and inhabit space sustainably while also bringing back benefits to Earth. As part of our efforts to enable space exploration, and in particular, prepare to go back to the Moon and eventually travel to Mars, ESA works alongside the scientific community to carry out various experiments through microgravity platforms and several ground analogues that mimic space conditions. One of the most significant changes experienced by astronauts is weakening of bones and muscles in the space environment. So currently, astronauts engage in daily exercise for up to 2.5 hours aboard the International Space Station. So this is a lot of crew time that's spent every single day exercising to mitigate these changes. But more effective techniques are being explored right now. One such potential technique is electrical stimulation, which ESA is now planning to test on board the ISS. If this is proven successful, this particular technique will not only contribute to the well-being of astronauts while they're in space and exploring further and further beyond our planet, but it also is going to improve ground applications, such as benefiting the elderly, people in critical conditions, and even athletes.
Space stressors like radiation and reduced gravity can result in bone loss and muscle atrophy, which can have serious consequences for the health and safety of astronauts. To ensure mission success, it's crucial to find ways to counteract or minimize this effect. The muscle stimulation experiment aims to address this issue by applying small electrical current to the leg muscle of astronauts on board the International Space Station to increase their muscle mass performance and recovery after return to Earth. Additionally, the experiment will include complementary measurements such as muscle MRI scans, microcirculation analysis and blood samples that will allow us to better understand the effectiveness of this promising technique.
When we study health and implement health protocols for the astronauts, they do well not only in the preparation to the flight, but also during their permanence in space and when they come back. I profited from all the research. For the first 10 years on the space station, we had a lot of questions about how can we properly execute a protocol, a health protocol for the astronauts so that they come back in on Earth and be ready to go right away, with a little bit of recovery time. After the first 10 years, we developed new machines that now we be implementing. I started working on those machines right away, and I had a fantastic time both on orbit and coming back. I was ready to go to recover in very little time. In around 4 to 6 weeks' time, astronauts nowadays, on average, go back to their initial conditions.
Space exploration is an ongoing journey that benefits both astronauts' lives and ours. The groundbreaking discoveries made thus far are only the beginning, and this pursuit will persist in the quest to sustain life on other planets, while simultaneously improving life on Earth.